Hello everyone, this is Professor Chan for Math 1245 speaking. We're going to continue on finishing the last part of 3.3 and we're going to start with 3.4. So the last part in 3.3 I wanted to talk about is this concept called remainder theorem. So if you take a look at this packet here, alright, let me zoom in, okay? So the polynomial remainder theorem is essentially just another way of finding out if we have a remainder other than using synthetic division. Now, just like synthetic division, we also can, this only works if you're dividing by x minus c, so keep that in mind, okay? So if I have 4x cubed minus 3x squared minus 8x plus 4, and I have x minus 2, just like synthetic division, I'm using the opposite sign, right? So instead of saying x minus 2, I say my x value is 2. Now, instead of doing synthetic division, what I'm going to do is I'm going to plug in 2 for the following. So I say f of 2 is equal to 4 times 2 cubed minus 3 times 2 squared minus 8 times 2 plus 4. And I'm going to simplify this. So if I calculate this out, I have 8. So what does this 8 represent? That is actually the remainder for if I divided this, okay? And let me show you too. So if we go back and we did synthetic division for this, watch what happens here, right? So I have 2. Remember, let's just do a quick recap of synthetic division, right? It's 4, negative 3, negative 8, and 4. So I'll bring down 4. 4 times 2 is 8. 5 times 2 is 10. Combined it's 2. 2 times 2 is 4. And what do you notice, right? We have a remainder of 8 as well, okay? So both synthetic division and remainder theorem works, right? So a remainder theorem is you plug in your x value, and whatever your y value is, that's actually your remainder, okay? Yeah, let's just look at one more example. Yeah, let's just look at number 1. So my x will be equal to negative 3, and then I'll plug negative 3 into my function. Okay, so I plug everything in. This is negative 4 times negative 27 plus 5 times 9 plus 8 here. Okay, so I have negative 4 times negative 27. 108. 108 plus 45 plus 8. So I'm going to do the following here. 104 plus 108 plus 45 plus 8. And that is 161. Okay, so that would have been my remainder. If I did synthetic division, I would also get 161 as well. Okay, so the next thing we're going to talk about is this concept called potential zeros. Okay, so what is potential zeros? Potential zeros are essentially a list of numbers we think would be our zeros, so that if I plug that in, I would not have a remainder. Okay, so so the formula is P over Q, in which P is my last term coefficient, which is all the factors, and Q is my first term coefficient, which is all my factors. Okay, so let's look at an example here. Okay, so I have f of x equals 2x cubed minus 5x squared minus 4x plus 12. Okay, so my first term, actually let's do our last term first. My last term is p, and it's going to be equal to 12. And so my factored form, I'm going to write all the numbers that divide into 12. So that'll be 1, 2, 3, 4, 6, and 12, right? All of these numbers divide into 12 evenly. Then I'm going to look at my q, okay, which is 2, and that is going to be 1 and 2. Okay, so what are my potential zeros? So I'm going to follow this right here. Which is going to be the following here, okay? So I'm dividing each of my p's by my q's. So I'll divide all my p's by 1. So that will just be, right, plus or minus 1, 2, 3, 4, 6, 12, right? All those divided by 1 would be the following, okay? Then I'm going to take all these and divide them by 2. So 1 divided by 2 is 1/2. Now here's the thing, 2 divided by 2 is 1, but I'm not going to write that down because that's going to be, that's just a duplicate, so it's irrelevant to repeat the same thing twice. 3 divided by 2 is 3/2. But then 4 divided by 2 is 3, 4 divided by 2 is 2, 6 divided by 2 is 3, 12 divided by 2 is 6. All three of those are already repeated I already have in my list. Okay? So this here is my list of potential zeros. Okay. So what does that mean? That means in this list of 16 numbers, some of them, if I plug them in, will give me a remainder of 0, or they would make, or that root will become a factor for my polynomial. Okay. So let me do one more. So let's look at this one here. P is 10. So my factors will be 1, 2, 5, 10. And then Q will be equal to 6. And it'll be 1, 2, 3, 6. So what is my potential zeros? This is plus or minus. So divide all of them by 1. So I have 1, 2, 5, 10. Okay. And then let's see, divide all of them by 2's. So I have 1/2. 2 divided by 2 is 1, so that's a duplicate. I have 5/2, but then 10 will be 5, so that would be a duplicate. Divide all these by 3, so I have 1/3, 2/3, 5/3, and 10/3. And then divide the rest by 6, so I have 1/6. 2/6 is 1/3, so that's redundant. 5/6, and then 10/6, which would be 5/3, and that's redundant as well. Okay. Now, if you write it like this on the test, that's fine. Okay, I don't really care too much. The thing that you have to be a little bit careful about is on my math lab when you're doing your homework, they do want you to write this in order, in numerical order. So you do have to be a little bit careful with that. So let me rewrite it from smallest to largest. Right, so it'll be like this. I'll do 1/6, 1/3, 1/2, 1/2, 1 2/3, 2 5/6, 5/3, 5/2, 5 10/3, and 10. Okay, also don't forget to put your plus or minus in front for the following right here. Okay. So let's talk about why we need to use this, okay? So the idea is you will have a polynomial, and the situation at hand is the following, okay? You want to figure out all of your zeros, okay? And let me kind of talk about the 4 steps to do this here, okay? So the first thing you want to do is you want to look at what's called your highest degree, okay? So I look at my highest degree, which is, in our case, it's x cubed. That means I have 3 zeros, okay? We'll get into that, what kind of zeros they are, but idea is we have 3 total zeros because whatever your highest degree is, that's the maximum number of zeros that we have, okay? So let's talk about the following. So the first thing we're going to do is we're going to first find my potential zeros. So my P is going to be 20. My Q is going to be 1. And I'm dividing, so Q is 1, which is easy. P is 20, so it's 1, 2, 4, 5, 10, 20. And I'm dividing all of them by 1. Okay, thankfully for us, that makes things a little bit easier. So my potential zeros is plus or minus 1, 2, 4, 5, 10, 20. So if you look at this right here, we have 12 potential zeros, right? We have 12 numbers that could be zeros. Now the thing at hand is, right, according to my polynomial, I only have 3 answers, okay? The thing is, I am not going to do synthetic division or remainder theorem 12 times because obviously that's going to waste a lot of time and it's kind of pointless to just keep plugging things in when 9 out of 12 times it's not going to work, okay? So there's actually an easier way to deal with this, okay? The better way is we just kind of look at our graphing calculator, okay? And I'm going to graph my polynomial. So my polynomial is the following. It is x cubed plus 8x squared plus 11x minus 20. Okay, and I'm going to graph this. Now, actually, before I graph, I do notice, right, my window goes from, so here's the thing, I could have a 0 from negative 20, and I could also have a 0 at 20. So I want to make my windows relatively wide. So my x min is negative 25, my x max is 25, okay? Why am I doing that? Because I know my largest and smallest number is 20, so I just want to see, I want to make sure I capture all my potential zeros for the following here, okay? So I'll hit my graph, okay? Now, here's the thing, I can clearly see that it's definitely not going to be negative 20 to 20, so I can make it smaller. Okay, go back to your window and readjust so you can kind of see, right? So I can take a look at this here, and it definitely looks like it's negative 5, negative 4, and 1, okay? So let's talk about this. So how do I know if I have a 0? What I'm going to do is I use synthetic division. So if you look at back in my calculator, I think one of them is, let's say, -4. Okay, so I'm going to do -4. I'm going to use my polynomial, which is 1, 8, 11, 20. Sorry, -20. Let's do our synthetic division. 1 times -4 is -4. And I just keep repeating. Okay, and I have a remainder of 0. That is a good thing. Okay, so if I have a remainder of 0, that means it's a factor. Okay, if it's not, either I did something wrong or I don't have the right number as a factor. Okay. Okay. And then I can keep going if I want. So what I'm going to do is I can continuously keep going and divide again. And I said x equals 1 also works. I do 1 times 1 is 4, 4 plus 1 is 5. And I have 5 here, and that also works. And I can do -5. Okay, and notice as I'm going along, I'm going to keep reducing, and that one also works as well. Okay, so my solution is x is equal to -5, -4, and 1. Okay, these are called my zeros. Okay. Okay, and then I'm going to write it in what's called part 4. It says write your polynomial in factored form. So since these are all my answers, right, all my zeros, remember in factored form you go opposite. So I have x minus, so I have a 0 at -4. My factored form is x plus 4. So I flip it around. Okay, I have 1, so it's flipped around as x minus 1, and this one will be x plus 5. Okay. Now, it does not matter which order it should be, right? Because we're multiplying my factors, right? So if I'm multiplying factors, it doesn't matter what order it can be, right? X plus 5 can go first, or it can go in the middle. It doesn't really matter. Okay? Now, let me also establish a couple more points when we talk about potential zeros. Sorry, when we're doing finding these polynomial zeros. The first thing I want to talk about is it actually does not matter what order you go first, right? So if I start off with -5 for my synthetic division, it still will work out at the end. I'll still get all 3, okay? So I can start off with -5, I can start off with 1, I can start off with -4, right? And as long as I keep reducing, so always remember this, always keep reducing as you go along, okay? And you'll get your answer. Now, a second way we can do this, okay, is the following here, okay? So let's say, let me do it in different color here. Okay, so let's say, right, we did this first part, right, and we have 1, 4, -5, right? At this point, if you remember back in our last video, I can turn this into a polynomial. This is actually x squared plus 4x minus 5, okay? And I can set that equal to 0. So once you're at degree 2, you can actually just factor it, or you can use quadratic formula. And you're like, oh wait, this factors to x plus 5 and x minus 1. And then notice when I set them equal to 0, I get what I have originally. Okay. So another way to do this is once you're down to degree 2, just write it as a polynomial, and you can use quadratic formula or factoring if possible, to find your other answers, okay? But always reduce it to make sure you're at least at degree 2, okay? So, yeah, make sure you write your solutions or your zeros, and then write it what your polynomial is in factored form. Okay. Okay, so let's look at another example. Let's take a look at number 2 here. I'm going to give myself some room. Okay. So, potential zeros here. I'm going to list. So notice I'm going to have 4 solutions because I have x to the 4th. Okay. And then I'm going to do the following. So I'm going to look at my potential zeros. So I have p. P is 8, which is 1, 2, 4, 8. And then I have q, which is 1. So my potential zeros, I'll call it PZ for short, is plus or minus 1, 2, 4, 8. So I have 8 possibilities, which actually isn't that bad, but the idea is only 4 out of the 8 will work. Okay? So let's graph this right here. So x to the 4th minus x cubed. Sorry about that. Okay, so since my smallest is -8 and my largest is +8, my window will just go from -10 to 10. Let's graph this, okay? Now let's talk about this right here, right? So remember back from our last video when we were talking about polynomials and how they cross or touch, right? So if you notice, it crosses at -1 and -2. But notice at x equals 2, it kind of bounces back. So remember, this is an even multiplicity. So that means at a minimum, we would have 2. So this is going to be a little confusing, but x equals 2 will be repeated twice because it would have a multiplicity of 2 because it touches. Remember, so if it touches your x-axis, you have an even multiplicity. Okay. One thing too is remember in your calculator, you can go to your table and you can kind of see when it's 0, okay? Remember what we did here. You can also use second trace and go to value, and you can type in a number that you think would work. So if I look at my potential zeros, I'm like, okay, well, let's see if -2 works. It does right there, okay? But more importantly, I notice it touches at x equals 2, so I'm going to do this twice. So I'm going to do synthetic division using x equals 2. I'm going to do it twice because it is a multiplicity. So 1, -1, -6, 4, 8. So I'm going to bring it down. 1 times 2 is 2. Combine, and I repeat until I get to my following here. So okay. So this works right here. So this cancels out, right? And we have no remainder. Now, remember, once I get to here, if I have 3 numbers left over, I realize this is a degree 2 polynomial. So I have x squared plus 3x plus 2, and then I can just factor it like normal. Okay, I'm going to solve for x, so I have x is equal to -2, and x is equal to -1. So my zeros, I have x is equal to -1, -2, 2, and this is multiplicity of 2. And then my polynomial is going to be the opposite, right? So it's going to be x plus 2 times x plus 1 times x minus 2 quantity squared. So this is my final answer, okay? The square is coming from the fact that I have a multiplicity of 2 here. Okay, so let's do one more. Actually, you know what? Let's do 2 more. So let's look at number 4 right here. So same thing. I notice I have 3 solutions of x cubed. And then I'm going to look at my potential zeros. I have p is 9, which is 1, 3, 9. And then q is 2. That becomes 1, 2. Okay. Now some of you guys are like, why am I not doing -9 for p? Okay. The reason why I don't care about the negatives is, remember, at the end of the day, right, I'm still doing plus minus p over q. So it doesn't matter if they're negative or not negative. I'm changing signs for both anyways. Okay, so I'm dividing all these by 1 and all these by 2. So I have plus or minus 1, 3, 9, and then plus or minus 1 half, 3 halves, and 9 halves. Okay. Okay. You can write them. Just make sure you rewrite them back in order. For me, I personally don't care on the test, but in your homework, make sure you go from smallest to largest in numerical order. Okay. So we're going to graph this. Check. So I have 2x cubed minus 13x squared plus 24x minus 9. I'm going to graph it. Okay, so notice here, I notice that it touches for the following. Okay, and notice it's also between 0 and 1 for the following here. Okay, so I think it's 1/2. That's one of them. So let's check. Type in 0.5, and we're good. My y value is 0. Okay, so let's do this here. So I'm going to do 1/2, and I'll do 2, negative 13, 24, negative 9. So 2 times 1/2 is 1. Negative 13 plus 1 is negative 12. Negative 12 times 1/2 is negative 6. 18, 9, 0. So this one here is 2x squared minus 12x plus 18. Notice when you're factoring this, you need to pull out a 2. And I'll factor this. And this makes sense because notice it touched at x equals 3. So that means I have a multiplicity, right? I have a multiplicity of 2 because it was touching the x-axis, right? If I look back at my graph. Okay, right? It comes up and it touches the x-axis here. Okay, so my zeros is 1/2 and then 3 with a multiplicity of 2. Okay, you can also write 3 twice. technically that's fine too. Okay. Now when you're constructing your polynomial, let's talk about this here. Here's the thing, on the test, I don't really care if you have a fraction. Okay? So, right, so my root is x minus 1/2 x plus 3 squared, and then I also have this 2 out here, right? If you write it like this, okay, it's not wrong. The thing is, when you're doing MyMathLab, is they don't like fractions in your factors because technically it's not a factor. They generally want polynomials that are whole numbers. Sorry, factor polynomials are whole numbers. So how do we take care of that? If you notice, you have a 2 in front, so all you would do is take your 2 and distribute this across. So then you just end up with 2x minus 1 times the quantity x plus 3 squared. That works out as well. Okay, so let's look at one more. I'm going to go to number 6 here. So my potential zeros, let's take a look at this. Sorry, so I have 3 solutions. My potential zeros, I have P is 4, 1, 2, 4. My Q is 1, okay? So that means my potential zeros is equal to plus or minus 1, 2, 4, right? And this one just on the surface doesn't seem so bad. Now notice what happens if I graph this here. So I'm going to graph this. Now here's something really interesting, right? We said our only potential zeros are 1, 2, 4. And now if you notice, if you look really closely at your graph, I have things that's crossing in between whole numbers. And that doesn't seem right, okay? So we'll talk about that in a bit. But then if you're not sure, look at the ones that actually does match your potential zero. I think it's -2. If you're not sure, check. So I'm going to do second trace, do value, I'm going to do -2. I'm going to type in -2. Notice I have y is equal to 0, so we're good. Show your work, okay? You always want to show your work when you're doing with synthetic division. So I have -2. I have 1, 6, 6, -4. So I have 1, -2, 4, -8, which is -2, and then 4, and that works out here. Okay? So this is going to be important right here because this can happen several times. This, you realize, is not factorable. Okay? So these two zeros here, they're actually in radical form. Okay? Your potential zeros, since it's always whole numbers or fractions, will not get radicalized solutions. So you will have to use quadratic formula, right? So I have a is equal to 1, b is equal to 4, c is equal to -2. Okay? So I have x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So I have -4 plus or minus square root of 4 squared minus 4 times 1 times -2 all over 2 times 1. Make sure you reduce this. So this is negative 4 plus or minus square root of 4, square root of 6, all over 2. Negative 4 plus or minus 2 square root of 6. Okay, what we're going to do is we'll divide each one by 2. So I have negative 2 plus or minus square root of 6, okay? So let's talk about this here. What are my zeros? My zeros are, I'll have x equals negative 2, okay? You can, and then the next part you can write negative 2 plus or minus square root of 6. Under my math lab, you do have to separate them. So this is let me show you how to write that. So I'm doing them each one separately, okay? Now, your polynomial, how do I write my polynomial? Notice you only have one factor. Let me, scroll down a little bit. My polynomial, when I factor it, the only one that worked was negative 2, right? So I will put down x plus 2. Now, some of you guys are wondering, where do I get the rest of it? We actually got it. We got it from after our synthetic division. So notice the 1, 4, negative 2, or the x squared plus 4x minus 2, okay? Because this is not factorable, I'll leave it as it is. So I'll bring this part down, and that is my final answer. Okay? So please practice finding all your zeros for your polynomial. Make sure you know how to write it in factored form. We will be doing a lot more of these in the next video. If you have questions, let me know. But other than that, have a good day, and we'll continue on.